Our sun provides the energy as electromagnetic radiation. These rays move through the atmosphere, and as they get into our atmosphere, they move through space, and as they get into our atmosphere, they start to impact or interact with particles, gases, and ultimately the surface of the Earth. At each interaction, a couple of things can happen, and it depends a bit about what it is that these rays are interacting with. So when they hit a particle or a gas molecule, some of the radiation will be reflected, and it gets reflected at the same wavelength. Other aspects of the electromagnetic radiation may be absorbed. And when the energy is absorbed, the internal energy of that particle, that gas molecule, increases, and because it's greater than 0 Kelvin, it then radiates energy, and the amount of energy and the wavelength at which the energy is re-irradiated depends on the Stefan-Boltzmann's law, which is essentially proportional to the fourth power of temperature. Very well understood. These rays that are being re-radiated or re-emitted are at a very, very different wavelength. The incoming radiation from the sun is in the short wave range, but these guys are in much longer wavelengths, more in the infrared range. And so they impact the thermal characteristics of the atmosphere significantly. When the radiation gets down to the surface of the Earth, some of it gets reflected, and that depends on the surface albedo. So for example, snow and ice will reflect almost all of the incoming solar radiation, and some of it will get absorbed. And just like with the gases and the particles, the absorbed solar radiation will heat the surface up and will get re-radiation in the longer wavelengths. Energy is also transferred from molecule to molecule. And this is particularly noticeable when you've got a nice hot surface with a quiescent layer of little gas molecules sitting on top of it. The energy from the surface will move up into the cooler gas molecules. And if there's a gentle wind, those warmer molecules will waft away and be replaced by the colder molecules. And the system will continue until there's no longer a temperature gradient. That's quite a slow process. If, however, the little warm molecules are wicked away quickly as a convective or a turbulent environment and replaced with very cold molecules, then we will find a much quicker transfer of heat from that hot surface into the atmosphere.